Hello everyone, we are from Engineering Team Project Group 34. This is the group members where we have Muhammad Anas and Sayyidatina Syuhada from Mechanical Engineering Department, Muhammad Faiz and Sayyidatul Husnia from Chemical Engineering Department, and Lee Zochun from Electrical Engineering Department.
Hi, my name is Muhammad Faiz. I will be presenting the introduction part. As we all know, Malaysia is one of the countries that have uniform temperature, high humidity and also have abundant rainfall. Due to ample supply of water from abundant rains in our country, this project will cease the use of rainwater to produce storable electricity. As the water demand is increasing rapidly results from growth of human populations, the demand of electricity becomes so high in every year. And this project follows SDG 7, Affordable and Clean Energy, and also SDG 9, Industry, Innovation and Infrastructure. Problem statement. Insufficient income to install electric generator becomes one of the major problems that lead to our inventions. Besides, the unreachable location to secure electricity and instability of power supply also become the problem that we want to overcome. Hence, there are three objectives that we want to achieve, where the first one is to utilize rainwater to its fullest. Second is to produce safe and comfortable converter to the consumer. And lastly, to lessen the burden people in rural or remote areas. There are two target consumers, where the first one is poor or needy people in rural areas because of insufficient money and also their outreach of electricity. The second target is people in heavy rainfall areas because of their need of emergency power supply and also high frequency of electric usage for daily basis.
Hi, I am Husnia and I will continue this presentation. In structuring Smart Rain to e-converter, we did some literature review and this can be divided into 4 parts. First is the idea. So actually, our product is inspired by rainwater harvesting system in agriculture. From that, we think to fully benefit the water, so we relate to the first law of thermodynamics, where the energy can only be transferred from one form to another. As the degradation of quality happens due to the entropy of the system is always increased. Based on the second law of thermodynamics, we try to handle this by adjusting to sustain the resource. Secondly, to maintain the smooth flow of water, the pump is used as the water pressure reduced over time due to the friction. For power supply, turbine is used to convert kinetic and potential energy into the electrical energy. So then the power is stored in the battery and can be used like power bank. Lastly, to achieve smart and user-friendly, sensor is installed to the system to detect the water level, and then it gives signal to the system to operate automatically. For this part, we use survey as design thinking tool to collect opinion from other people. Our survey consists of 10 questions which include their location, rainfall distribution, theory, benefit of storable power, benefit to society, concern of our product, interested in purchasing together with the estimated price range, relevancy and recommendation. To sum up, our project get the positive feedback, achieve smart criteria and can proceed to the next stage. Moving on to the alternative design selection. At first, the components are connected into several parts, such as the flow for water storage, generate pressure by pump, and the conversion of energy. Second, it is arranged to the design 1 and then being modified to design 2. Here is the comparison between design 1 and design 2. It shows that design 2 has more advantages from design 1 as it is convenient for the user and also to the system. Modification keep continuing and we came out with this finalized design. Next, I will pass the presentation to my group member.
Hello and hi, my name is Anas and I will talk about our project planning. First, we go to the task distribution. I, as the project manager of this ETP group, take the role to distribute the tasks equally among the group members. I also produce the Gantt Chart to supervise our project progress and also do the project animation video using the Fusion 360 software. Next, our secretary, Faiz Asrul, works on the introduction part of our project, include the project background, problem statement and objective. He also assigned to edit our project video and also works on producing the project e-poster. Moving forward, Sayyidatul Husnia, our research manager, was assigned to do some research through the literature review and apply the design thinking tools by doing the surveys to get information and feedbacks from the public. She's also given the task to edit our project video. Besides that, our designer, Sedatina Shohada, were assigned to produce the CAD model drawing using AutoCAD software and also come up with the design schematic. She also works on the justification of design selection. Lastly, our treasurer, Lizwa Jun, works on material selection and also manage our project budget through the economic considerations. He also works on producing the circuit simulation video. This is our Gantt chart. This Gantt chart includes our project progress from week 2 until week 12 of this semester. This Gantt chart functions to supervise our progress so that the project progress will be smooth all the way and always meet the deadline given by the coordinators. Next comes the methodology part. This flow diagram shows our project workflow. The project workflow starts by identifying the problems. We as a group try to come up with the relevant problem statement developed based on the SDG goals to begin our project. After that, we start brainstorming for the relevant ideas of the project based on the problem statement. We shortlisted some of the ideas gained from our brainstorming stage and brought it to the meeting with our supervisor. And then after got some comments and suggestions from our supervisor, we decided to begin our project with this Smart Rain to E-converter idea. Then we start give the roles and distribute the tasks among the group members. We start to make the progress by starting to design the prototype and configure the circuit system. We also begin our work on extended proposal and fabrication of demonstration model. Then the next step is we initially test the prototype using simulation software before we demonstrate it to the supervisors. After got some comments and approval from our supervisor, we proceed to produce presentation video and e-poster. While doing that, we also started our progress on the final report. And then lastly, we end our journey to this project by submitting the final report to be evaluated by the coordinators. This flow diagram shows our project working principle. Generally, our product is to convert the kinetic energy from the rainfall collected and convert it to the electrical energy for our customer usage. This working principle will be explained further in our demonstration video. These are some of the vital components in our product. Firstly, we have the Arduino Uno as the main controller in this project. It will serve the purpose in this project to handle all the sensors, which are the ultrasonic sensor, water pump and solenoid valve, to ensure the operation of each component is smooth. And then we use ultrasonic sensor to measure the height of the rainwater collected in the tank. This can ensure the hydro turbine can continuously spin for a long time and reduce the power loss when water flow through the hydro turbine due to the internal friction and so on. Other than that, a mini diaphragm pump is also implemented to increase the water pressure to flow through the hydro turbine. This water pump is small and powerful enough which surely meet our expectation. And lastly, there will be 6 hydro turbines which connected in parallel so that same water pressure can be produced to maximize the power generated. We believe this hydro turbine can generate about 12 volt with greater than 220 mA at the maximum output.
When the rainwater starts flowing into water tank, the distance detected by the ultrasonic sensor starts decreasing. Once ultrasonic sensor reach the distance of 6 cm, it will on the water pump and solenoid valve for 3 seconds. After 3 seconds, water pump and solenoid valve will off until next cycle. In our prototype, the time will be set to 30 minutes.
Hi, my name is Sedatina Shohada and I'll be presenting on the demonstration of the design concept and on the result and discussion. So first, we will start with the demonstration of design concept. So I'll explain the design concept based on this animated video. Okay, firstly, how does the converter works? When it rains, the gutter will collect the rainwater and drain it into 200 liters of plastic drum. As the rainwater reaches up at the height of 86 cm of the drum, the ultrasonic sensor that is placed at the top of the drum will send an ultrasonic sound wave to open the valve and to activate the pump. Before that, I'll explain the function of the pump and the valve. Okay, as you can see here, the function of the pump is actually to increase the pressure and the velocity of water throughout the system, while the function of the valve is actually to prevent the backflow of the water. The function of the turbine is to convert the mechanical energy to generate an electrical energy. So as I said, the sound wave will open the valve so that the rainwater will be pumped throughout the solenoid valve to reach the turbine at the speed of 0.1 liter per second to generate the maximized power generation and convert the mechanical energy to 15.84 watt of electrical energy. All this power will be supplied to the power bank module that will charge the battery and supply the power supply to the household. The entire system will be working inside a box to maintain its performance and to prevent any damage, so that this system will work at its best. First shows the price for each component used in this converter. The total estimated price is RM434.40, and based on the survey conducted, 81.8% would consider to buy the product, with the price in the range of 400 to 500 ringgit, which makes the estimated price is in the range of affordable and reasonable price. Our product is designed to be environmentally friendly, where we don't produce any type of pollutant at the end of the process, and it complies with the HAC requirement to produce a safe engineering product for both human and environment. The most important thing is it is user-friendly, where it is very convenient and easy to use. Based on the survey conducted, 86.4% agrees that our project is user-friendly and is safe to environment, while 63.6% believes that our product will be beneficial to the community to overcome their problem.
Hi, I'm Jojun from E Department, and I will be presenting conclusion and recommendation part in this video. In conclusion, Smart Rain 2E Converter is a power generation device by using green energy, which is the natural rainwater. The main purpose of it is to help community, especially poor and rural areas where they are having difficulty to get the electricity. Besides, it is also a power efficiency product, as the power generator will be stored in the battery. For recommendation, a Wi-Fi program or monitoring apps can be implemented so the user can always aware on the next maintenance period, and they can also monitor the energy level of the converter. Then, it can include filter system for the design to avoid any unwanted waste by flowing into the water tank. It can also implement an automatic switch breaker to avoid any accident, such as the short circuit of the components. That's all from us. Thanks for watching this video.